Star Trek introduced the world to many things. The Klingons, the Enterprise, some frighteningly dedicated fans, and the Replicator. The Replicator is a device to create anything as long as it has the necessary blueprints. And the coolest thing is, it kind of exists. 3D printing is our real-world spin on Star Trek's Replicator, a device to create anything you want on the spot. The technology has actually existed for a few decades, but has been mainly used for prototyping and specialized jobs. But, as The Guardian reports on January 22nd, 3D printing has come a long way from its inception and is spreading to many new areas, including the construction business. Firms are seriously investigating the virtues of printing panels, walls, and even entire buildings. Today, we will take a look at the foundation of 3D printing's use in construction, see how it has entered the industry already, before taking a look at the implications of automated construction. As Business Weekly reports on January 7th, 2013, 3D printing is more widely known as an additive manufacturing process. Much like an inkjet printer takes a digital file and prints the ink into desired form, line by line, a 3D printer takes a digital file and builds step by step. The machine takes a 3D computer model of whatever is to be printed and chops it up into microscopic vertical slices. Then, layer by layer, the machine deposits a thin film of material in the shape of the current slice. These layers build up until a complete object appears where nothing was before. By introducing instant replicability to the third dimension, 3D printing has found great use in many industries. The widespread acceptance of 3D printing has led to new applications that make it more broadly useful. As The Economist reports on May 21st, 2012, 3D printing's historical use has been rapid prototyping, or building something for proof of concept before it has to go to the assembly line. Now, however, more people are using 3D printing for other uses, because they're noticing a few key advantages. First, 3D printed objects can be made incredibly complex with little to no effort, and each individual unit can be customized with the same little to no effort. Secondly, 3D printed objects use much less material as they build up rather than shaving away. Finally, 3D printed objects are automated and require only one machine for the entire process. If such a process could be scaled up to the size of a house, the construction industry would be ecstatic. Now that we know why the construction industry is interested in 3D printing, let's take a look at how it has entered the industry already. Concrete is the world's most popular artificial material. It's sturdy, fireproof, and a staple in construction. But, as the New York Times reports on January 16th, 2013, even concrete has its limitations, and architects are stuck with designs that can be easily and conventionally sculpted. Fortunately, the Freeform Construction Project at Loughborough University realized that a modified form of 3D printing could be used to alleviate this constraint. By just using a nozzle to extrude a thin layer of concrete, the team was able to allow the concrete to set in enough time to treat it just like any other 3D printing substrate. Using 3D concrete printing, the team was able to create a wide variety of complex building pieces not normally achievable with cement, including the world's first double-curved concrete panels. Additionally, Freeform has shown the capability of printing pieces with tightly controlled voids and spaces, meaning pieces of a building can come pre-installed with setup for air, plumbing, or wiring. The Freeform construction has proved that concrete printing is a valuable addition to the toolbox of construction. The Loughborough team introduced the world to concrete printing, and other firms have set out to refine the process. Dr. Baroque Koshnevis of the University of Southern California started his own process and company called Contour Crafting. The purpose of contour crafting is to make concrete printing bigger, faster, and more ambitious. The bigger requirement was accomplished by just building a bigger frame for the printer. According to World Architecture News on January 18, 2013, Contour's current machines can easily print objects up to 7 by 15 by 23 feet, and they are constantly expanding. Printing speed was increased by allowing the concrete streams to extrude in layers as thick as 1 inch, compared to freeform's few millimeters. Of course, the accuracy of a printed object depends in large part on the thickness of the layers, so fatter layers and faster speeds brings the danger of rougher edges. The workaround employed by Contour consists of a trowel on the side of the nozzle that sculpts the concrete as it sets, smoothing out rough edges much like a potter's hands. Thus, the advantages of thicker layers are kept, with a much lower loss in resolution. Contour Crafting has upped the process of concrete printing and is ready to move into the industry. Concrete printers have already shown fantastic progress in printing concrete structures, and with just a little imagination, one could see such a device printing an entire house. In fact, that's the point. According to the Daily Mail on August 13, 2012, the end goal of Contour Crafting is the printing of a 2,000 square foot house in less than 1 day. To understand how such automation will affect our world, we will take a look at the implications in 2 distinct areas: low-income housing and inhospitable environments. Shelter is one of the most basic human needs, but obtaining adequate housing is still a fundamental problem for much of the world's population. Currently, over 1 billion people around the world live in slums, and as global urbanization continues, this number is only expected to increase. Fortunately, concrete printing is set to combat this global shelter shortage. According to Contour Crafting's homepage, last accessed February 4th, 2013, Contour Crafted projects have an estimated cost at 1/5 that of current construction techniques. Seeing as many residents of slums live there because they can't afford to live anywhere else, this drastic cut in costs combats one of the major causes of slum formation. Additionally, concrete printers have an advantage in their speed. Part of the reason slums form is that current construction methods can't build houses fast enough to meet large waves of urban immigration. Because of their intense speed, concrete printers could print entire communities of houses to meet urban immigration, rather than forcing these immigrants to build their own housing. These printed structures would be faster, more stable, and cleaner than improvised housing, allowing these people to have real homes in place of makeshift shelters. Concrete printing promises to revolutionize the way we view slums. In addition to fighting economic injustice, concrete printers are fast, automated, and easy to transport, all of the qualities one would want for building in extreme conditions. In an April 2012 TEDx talk, Coach Nevis details how concrete printing can revolutionize disaster response. After a natural disaster like an earthquake or a hurricane, infrastructure is often so damaged that rebuilding quality housing is impossible, so rebuilding quality housing takes far too long. However, by airlifting in a few concrete printers, many of these problems could be alleviated. Concrete printers would print new communities of housing far faster than emergency housing can be brought in, and these printed structures would be incredibly stable and contain setup for infrastructure, all the features of quality permanent housing automated at the speed and cost of traditional emergency housing. But, as BBC reports on February 2nd, 2013, by 2020, 3D printing will have reached even greater heights. The European Space Agency has announced plans to use moon dust as the basis for concrete and 3D print human habitable structures on the moon, hoping to usher in a new era of space exploration. I'm sure Newt Gingrich is stoked. 3D printing is set to ensure that construction has no final frontier. Almost everything you own, from the car you drive to the clothes you wear, has significant automation involved in its production. It's time for housing to follow the trend. 3D printing has found great use in many industries, and with increasing interest, concrete printing is set to take over the housing business. Houses will become more affordable for everybody, and construction can expand into new directions. So while Kirk's replicators may have just been used to get food to the deck, our 3D printers are set to ensure that we live long and prosper.